So here we're asked to rewrite each of the following radical expressions using fractional exponents instead of radicals. So what that means here is that if I have, a fifth root of 6 to the power of 11, that's the same thing as 6 to the power of 11 fifths. What you should notice is that the power here always stays in the numerator. It's always the highest number in the exponent. So I'm going to rewrite this here just to make it a little bit bigger and more helpful here. So 6 to the power of 11 equals 6 to the power of 11 over 5. So this one here, we're going to go through, and I got 5 to the power of 2/3. Then I have 2 to the power of 5/4. So again, anything that's in the root is really the denominator of our exponent. So don't forget, if there's no number here, that means a square root, so that's 3/2. Same thing with this one here, 7 to the power of 3/2. Another thing that I'm hoping you notice is that even though if we have one where the exponent is on the inside here of the root or the outside of the root, it doesn't change what we're talking about here. This one here looks like it's going to be 7. Oh, this one's a toughie. So this one is 7 times 7 to the power of 1/2. Now I'm going to use my exponent rules when I have the same base. Remember, there's like a little invisible 1 here. So now I can add these exponents. I can't just add because there's no common denominator here. So I'm going to change this to 7 to the power of 2/2 over 7 to the power of 1/2. Now I can add them to get 7 to the power of 3/2 for E here. Same idea with this one here a little bit. So we're going to have, what is this, 9 times 3 to the power of 1/3. I don't know if the book actually asks you to do this or not, but I know that 9 is 3 to the power of 2. So same idea from the last one. I'm going to go ahead and have the same base and now add these exponents. But don't forget, I got to get a common denominator. So I'm multiplying the top and the bottom by 3 and 1/3 here. And now I got 3 to the power of 7/3 as my final answer.